Hi, my name is Norasma Salsabila binti Zawawi. Now I want to explain about the problem statement of this project. The first problem statement of this project are require more manpower to produce the Cakoi. Second, extra time needed to make the Cakoi. The third one is traditional method lower the production of Cakoi. And the last one is Cakoi making machine does not exist in the market.
Hi, I am Nurusna binti Razali. I want to explain about the objectives of our product. The first objective is to reduce the time for making the Cakoi. The second is to increase the quantity of the Cakoi. And the last one is to reduce the manpower that used for making the Cakoi. Next, I want to explain about the public surveys for this product. For the design specification, most of the respondents chose agree for the design of Cakoi making machine. The design specifications of Cakoi making machine are portable, attractive and equipped with the commercial value and using a suitable material for this product. Next, the features needed by the respondent for this Cakoi making machine are long-lasting, easy to use, eco-friendly, and having the safety protection. Besides, the ergonomic specification needed by the respondent are the product not produce too much noise, light, and easy to moderate. The crucial part for this survey is cost for the Cakoi making machine. The respondents want the product should be low of maintenance, low operational cost, affordable price and minimum energy consumption.
Assalamualaikum and good afternoon to the panel. My name is Farano Arisa binti Muhammad Nizam. My metric number is AD170075. Today, I would like to present about the functional structure of our machine. There are three types of energy that we use, which are human energy, mechanical energy and electrical energy. For the material, we use ingredient of Cakoi dough and dough. For human energy, we use it when to put the ingredient of Cakoi dough into the mixer. And mechanical energy, we use it to turn on the machine. Furthermore, the electrical energy we use to start the motor and rotate the shaft. Next, I will be explaining about the process of our machine. First of all, the machine will be turned on. Second, the ingredient of the Cakoi dough will be put in the mixer and the mixer will mix the ingredient. After become the dough will enter the roller and the roller will compress the dough. After the dough being compressed, the dough will undergo the cutting process. That's all for me. Thank you.
For this part, I will tell you about our final product for the Cakoi maker machine. As you can see, this is our final product, Cakoi maker machine. We use a dough mixer, and then the dough mixer will move to the conveyor belt and then move to the roller and form a rectangular shape of the dough. And then we move the dough to the roller cutter and cut the dough into the long piece of dough. And then we move the dough, the conveyor will move the dough to the rectangular cutter and cut it into the pieces with the rectangular shape. And then we'll have the piece of dough. Okay, we move to the next part with the exploded view. For the exploded view part, as you can see, we have used a many part. As you can see, for the mixer part, we have used a mixer and the body for the mixer and the motor for the mixer. And then for the conveyor part, we have used a conveyor belt, roller for the conveyor belt, and the table for the conveyor. And also at the upper of the conveyor, we also use a cutter, two cutter, a rectangular cutter and the circle cutter. We use to roll the dough. And then we also use the roller to roll the dough. Then we will move to our third part is actually the static analysis for the simulation part. As you can see, for the static analysis, we have used to calculate the analysis on the table for the mixer, and then we use a certain analysis on the table for the conveyor, and also the last part I use the static analysis to analysis the cutter, the rectangular cutter, which is I apply the force for the table on the right side and the left side of the table, and for the conveyor I apply the force on the upper side of the table, and then for the fixed force I apply in the next of the table, and then for the cutter I apply force and on the upper of the cutter, and then I apply pressure on the bottom of the cutter.
Fatigue analysis. This analysis seems doesn't affect at all on the mixer rod. The analysis results show there is no failure occur in a long time period. The result value as shown in figure for damage percentage part. Next, the analysis also same for the roller part. There is no failure occur at the roller part and can be used for a long time period. For buckling load analysis, the critical buckling load is the maximum load that its body, mixer and conveyor table can withstand when it's on pressure of buckling. The buckling failure occurs when the length of the body, mixer and the conveyor table greater compared with cross-section. This analysis will utilize a high factor of safety for buckling load.
Now, we move to the element in sustainability. Sustainability is improving the quality of human life while living within the carrying capacity of supporting ecosystem. There are three elements of sustainability, which are economy, social, and environment. In economy, sustainability occurs when development moves towards social and environmental sustainability. As for social sustainability, it requires the continuity of society and the ability to work for the common goals in individual needs such as health, nutrition, shelter, education, and cultural expression. The last element is an environment. It requires natural capital remain intact. The source and skin functions of the environment should not be degraded. Thus, the extraction of renewable resources should not exceed the rate at which they are renewed. For this project, we are also focusing on the sustainability in the three elements. As for economy, we focus on affordable cost of Cakoi making machine, and also the design machine that use low cost and functioning well. In the social element, we are trying to reduce the use of manpower and also reduce the health risk from any pollution associated with energy construction. For the environment, we make sure that raw material extraction such as drilling and mining, processing and manufacturing are not dangerous to the environment.